Solve equations in quadratic form. So here's an equation. It has a fourth degree. We've never talked about something like that before. But it has a fourth degree and a second degree. That's in a 2-to-1 ratio. So if it was a sixth degree and a third degree, or an eighth degree and a fourth degree, it would work out as a quadratic form. So we add 6 to both sides, and now we're here. And now our goal is to get some kind of expression squared plus b times the expression plus c. So you get the 2-1 ratio. So I think you can see that if you let x squared be that term in there, it'll be squared to get the x to the fourth. It'll be to the first power to just get the x squared itself, and the plus 6. So if this was a squared minus 5a plus 6, you would just factor that as a minus 3a minus 2, and it would work out. So we're going to do that here. Here's your a, which is this, here and here, and then you're just going to factor the normal way, try to get the 6 with -3 times -2, so that works out to -5 in the middle, and then set each one of those equal to 0. X squared minus 3 has to be 0, or x squared minus 2 has to be 0 for you to get 0 on the right side. Then add the 3 over, x squared equals 3, add the 2 over, x squared equals 2, x therefore is a plus or minus the square root of 3, or x is plus or minus square root of 2. So here's all the solutions. So if you're wondering in the big picture of the graph what would be happening there, you graph it in the calculator. X to the fourth minus 5x squared plus 6, and it graphs this way as a sort of W shape, and this one happens to have 4 intercepts. 1, 2, 3, 4. And square root of 2 is about 1.414 something, and that's exactly where it looks like it is. Square root of 3 is about 1.7 something, and that's just about where it is. So your square root of 3 is the far right root, square root of 2 is the next one, negative square root of 2 is here, and negative square root of 3 is there. Now let's go on to another very similar problem. You have the 2-to-1 ratio of these exponents. That makes it a quadratic form. So we're just going to add the 2 over, and now here we have an equation. And I think you can see that if you let the x minus 1 be like the a, or the term inside, if you square it, you'll get back to x to the minus 2. So you have x to the minus 1, x to the minus 1. And then you factor that. Here's your variable. Here's your variable. The normal way where you get the 6 plus the 1 is the 7. And it's all going to work out. Then you say this is equal to 0, or this is equal to 0, using the 0 factor principle. Then you subtract 1 from both sides on this one, subtract 2 from both sides, you get here. Divide the 3 over on both sides, now you're here. Divide, or, oh, I did this in a different order. So now I'm ready here. Let's just stay on this side here for a second. So it's x to the minus 1 is 1 over x. That's what the definition of x to the minus 1 is. So 1 over x equals negative 1 over 3. So if you take the reciprocal of both sides, you're just going to get x, therefore equals negative 3 over 1, which is negative 3. And over on this side, x minus 1 equals negative 2. X to the minus 1 means the same thing as 1 over x. So 1 over x is negative 2 over 1, then x, flip it, will be negative 1 over 2. So your solutions are negative 1/2 and negative 3 If you don't believe the last step of doing this, flipping, then you take your equation, hit it with 3x on both sides, cancel out the x, you get this. You get the x on this side, the 3's cancel out, times both sides by -1, x equals -3. That's how it would work if you took more steps.